Hello everyone, this is Mr. Appel, and I'm going to introduce you to the parent rational function. So we're going to start with your first ever rational function, graphing it. We've been working with them in all kinds of ways, solving them and simplifying them. But now we're going to graph one. And these are going to behave very differently than anything you've ever seen before. It's pretty cool. You're going to learn some new fun words. So let's get into it. So the parent rational function is just 1 over x, y equals 1 over x, 1 divided by x. So a couple ways we can kind of approach this. One is to start listing some x values and kind of just see what happens. So if x is 1, let's say, well, that's just 1 divided by 1, which is 1. That's easy enough. So that's right here on my graph. Whoops, sorry about that. If x is, let's say, 2, let's put that back there. If x is 2, that's 1 divided by 2, which is a half. So I'm going to have to kind of zoom in here a little bit so that we can see the graph. So at x equals 2, I'm at a half. If x equals 3, that's 1 divided by 3, so I'm at a third. And so I'm here at a third. And so what's happening here, let's see if I do a 4, it's a fourth. If I go out to 10, it's going to be 1/10. So that's going to be way out here. So I'm getting really, really, really close to the x-axis. But what happens if I go out to like a million? If I go out to a million, well then my y value is going to be 1 over a million. So really, really, really tiny number, but still positive and not quite 0. And so that graph gets closer and closer to the x-axis. Now let's see what happens as I go. So over here from 1 on, it's doing something like this. It's getting closer and closer and closer, and it keeps going without ever actually touching the x-axis, which is kind of crazy. Now let's see what happens between 0 and 1. Well, let's say x is 0.5 or 1/2. Well, 1 divided by a half goes into 1 twice. And so when x is a half, I'm actually up, whoops, sorry about that. I'm actually up here at 2. If x is, let's say, 1/10 or 0.1, 1 divided by 0.1, 0.1 actually goes into 1 10 times, right? 1/10 goes into 1 10 times. So at 0.1, we're up at 10. So at 0.1, we're up, oops, sorry, that keeps jumping around on me, way up there. So as I get closer to 0, my x values, this thing actually starts doing this. It starts going up, 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 up. But think about this. Can I ever actually get a y value of 0? Well, if I'm going to get a y value of 0, a y-intercept, then this 1 over x would have to equal 0. Well, if that were true, then I'd have to think of some x such that, think about this for a second, 0 multiplied by x equals 1. So can you think of a number that when multiplied by 0 equals 1? Neither can I, because it doesn't exist. And so what happens is we have something called an asymptote. An asymptote is an imaginary line, in this case the y-axis. Let me move that over a little bit. An imaginary line that the graph gets closer and closer and closer to, but it never actually touches it. Now we also have an asymptote, another asymptote, and that's the x-axis. We touched on a moment ago that you can't actually touch the x-axis either, because as those x values get really, really big, the y values get really small, but they don't actually get to 0. Algebraically, let me get that out of the way, if x were 0, I'd be putting 0 into this thing, and we can't divide by 0. Can't do that. So this graph also approaches the x-axis, but never quite gets there. And so there's an asymptote there as well. And so the vertical asymptote is the line x equals 0. The horizontal asymptote is at the line y equals 0. And again, it's a dashed line because it's not actually a part of the line, but it's an important thing to know about. Okay, let's keep going. Similar things happen on the negative side. If you plug in -1, then you're doing 1 divided by -1, which would just be -1, no problem there. If you do, let's say, -10, 1 divided by negative 10 is negative 0.1, so that's going to be, say, around there. And so our graph in the negatives is going to do, whoops, that's really thick. Let's make that thinner. Going to do something like this. It's going to go like that, and then it starts going down, 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 and again, gets closer and closer to the y-axis, but never actually touches it. I have a little prettier version you can see that I did in Desmos. I definitely encourage you to graph this in Desmos and explore a little bit so you really understand what's going on. Now Desmos isn't going to show you the asymptotes, but you can kind of see this asymptote that the graph over here, over on the right, is getting closer and closer to the x-axis and also to the left. So we see that asymptote, and then also the same thing on the y-axis. We see that asymptote. So that's kind of the gist of what irrational functions look like. Again, very different than what you're used to. I'm going to introduce some vocab here. This is a discontinuous function because it has a gap, it jumps. One way to describe, so a continuous function is one that you can sketch without having to pick up your pencil. So for example, if you had like a quadratic, you can draw that entire, you can sketch it. There's no break in it, right? You can sketch it without picking up your pencil. But this graph, as I do all of this stuff, I have to pick up my pencil and go up here to continue it. So this is called a discontinuous function. The domain, well, let's think about domain. Domain is what are all the possible x values. Well, the possible x values, you can plug in any x value you want except for 0. And so your domain is going to be, let me go back to a thin one, is going to be negative infinity to 0, and then 0 to infinity. The range is the possible y values. Again, the only y value we can't actually get is 0. So it's going to be the same thing for the range. Negative infinity to 0. And then 0 to infinity. There are no intercepts because this thing never touches the x-axis or the y-axis. So that is your introduction to the parent rational function. That's all for now. Thanks.